Okay, I want to do another example with graphing rational functions and just summarize the whole procedure. I find it easiest to remember a mnemonic device that I refer to as Dr. It VH. Now, this year we're not going to talk about the T part of that, but we will continue with the rest of it. So, first off, D stands for domain. Okay, remember your domain is, we got to remember where the denominator is equal to 0 because the denominator cannot be equal to 0. So in this particular problem, I'm going to take x cubed minus 4x, set it equal to 0. I'm going to factor. It becomes x squared minus 4 after the common factor, and then I have a difference of 2 squares, so that's x plus 2 times x minus 2. That gives me my domain as all real numbers. If I set each of these factors equal to 0, x would equal 2, negative 2, or positive 2. So my domain is going to be all real numbers except x cannot be 0 plus or minus 2. That's your domain. Now we need to go reduce it. So using that factored form, if I take this over, my top is 4x, my bottom is x times x plus 2, x minus 2. You can see that that reduces. We have a common x on the top and the bottom. So now my reduced form is going to be 4 over x plus 2, x minus 2. And when you have it like that, that means that where the where the x's cancel, that's what we call removable discontinuity. Okay? We will come back, and that's of course where we have a hole in our graph. Okay? Intercepts. The I stands for intercepts. Okay? You have an x-intercept. What does x equal when y is 0? How do we find that out? We set the numerator equal to 0. Okay? The nice thing about reducing it is you always want to use the reduced form. So where is this numerator equal to 0? Where does 4 equal to 0? Never. It cannot be. There is no variable. So we have no x-intercept. To get your y-intercept, we're going to put 0 in for x and figure out what y equals. And that, of course, is plug in x equal to 0. Okay, if you put in x equal to 0, what are you going to get? Again, use your reduced form because we know that there's going to be a hole, but this still lets us know where our hole is going to be exactly. So if you put 0 in here, that's going to give us 4 on top, and then of course 2 times negative 2, which means I have 4 over negative 4 or negative 1. So what this is telling me is that I have a hole when x is equal to 0 and y is equal to negative 1. So it's a hole. Does that mean I have an x-intercept? Excuse me, a y-intercept? No, I have no y-intercept either. Because again, x couldn't be in our domain. Okay, our vertical asymptotes, we go back to our domain and find out what's left because this is the non-removable part. Non-removable. And so let's put this, the VA stands for vertical asymptote. And from my domain, that means that's going to be x equals plus or minus 2. So I'm sure you can figure out that h is the HA, or my horizontal asymptotes. Okay, and remember, to find our horizontal asymptotes, we're always looking at the degree. So go back and look at the degree. What's the degree of our top? Of our numerator is 0. The degree of the denominator is 2. So if the numerator is less than the denominator, then where is my intercept? Excuse me, my horizontal asymptote. If the numerator is less than the denominator, then you're going to have it at y equals 0. So we have a bunch of information that we got to go put on our graph now. Let's go see what we've got. We have no x-intercept. We have no y-intercept. We have a hole at 0, -1. We have a vertical asymptote at -2 and +2. And we have a horizontal asymptote at y equals 0. So we have all our information together. We've got all of our summary information. Now let's go put it on our graph. I'll summarize, minimize that. Okay, first off, we want to graph our asymptotes. So we have our vertical asymptotes at x equals -2 and x equals +2. And then we have a horizontal asymptote. I just write the equation because at this point it's kind of hard to see over our um, actual axis. Okay, we know that we have a hole at 0, -1, so we draw a little circle around that point. Okay, and we've also talked about the fact that it will never cross it will never cross a vertical asymptote, and we have no x-intercept. So that's enough information for us to tell us that our graph is doing this. From there, we have two other regions, and we're going to go test values in that region. I find it easiest to use the factored form, which is 4 over x minus 2 times x plus 2. So I'm picking a point in this region. That gives me the number 3. So if I pick the number 3, then I'm going to have 4 over 3 minus 2, which is 1, 3 plus 2, which is 5. So that gives me the point 4/5. So I have the number 3/4, which is there. And I'm going to connect it. Trying to, okay, not crossing because I know I don't have to. That's connecting my point. And then I'm going to go pick a point in this region. I'm going to pick -3. Again, plug it in. 4 over -3 minus 2 is -5. -3 plus 2 is -1. That gives me 4/5. So at -3, I have 4/5 again. And I'm going to make it approach my asymptotes like I know how. So that is the summary of graphing rational functions.